Now, accordingly, the following diversification rules emerge for a two security portfolio. Case 1, where RAB equal to 1, that means here the securities are perfectly positively correlated. That means if return of security A is increased by 1%, return of security B is also increased, will also increase by 1%. But if this situation prevails, that means if RAB become equal to 0, equal to 1, then there is no diversification effect, as the portfolio risk in such a case is always greater than the risk of least risky security in the portfolio. This means that portfolio risk in this case is simply the weighted sum of the individual security risk, which is shown as below. Now, as per the Markovis diversification principle, we know that the Markovis diversification principle is based on a mathematical model, and here, as per the Markovis diversification model, if diversification is made in a proper way by applying the mathematical model, it will reduce the risk of the portfolio, and the risk of the portfolio will be lower than the, even lower than the risk of individual security that contained in the portfolio. That means if the risk of security A is 5%, if risk of security B is 6%, then obviously portfolio risk will be lower than 5%. That means portfolio risk should be lower than the risk of the security contained in the portfolio, the lower risky security contained in the portfolio. So if the diversification is made in a proper way, then this situation will prevail. So benefit of making diversification is reduction of the risk. Now, if RAB is equal to 1, then there will be no diversification benefit. But in this case, portfolio risk can never be less than the risk of lowest risky security contained in the portfolio. Rather, here the risk of the portfolio will be the weighted sum of the individual security risk. Now, we know that in case of the two securities portfolio, the portfolio variance is equal to WA into sigma A whole square plus WB into sigma B whole square plus 2WA into sigma A to WB into sigma B into RAB. Here RAB equal to 1, so in place of RAB we have to put 1, then it will take shape of A square plus B square plus 2AB. Here A is WA into sigma A, B is WB into sigma B. So here the formula takes shape of A square plus B square plus 2AB. Now here it comes to A plus B whole square. Here A, WA sigma is taken as A, WB sigma B is taken as B. So it will take shape of A square plus B square plus 2AB. So it is A plus B whole square. Now sigma B square, that means variance equal to sigma WA into sigma A plus WB into sigma B whole square. Therefore, standard deviation of the portfolio, that means portfolio risk, will be root over of the variance of the portfolio, and it will be W into sigma A plus WB into sigma B. So here the portfolio risk in this case will be the weighted, will be equal to the weighted sum of the individual security risk contained in the portfolio, and in this case here the portfolio risk can never be lower than the risk of the lowest risky security contained in the portfolio. Hence, risk averse investors would therefore invest all his money in the lowest risky security. Thus, it can be said that favorable portfolio effect occur only when the two securities are not perfectly positively correlated. That means diversification will be there if the two securities are not perfectly positively correlated. If two securities are perfectly positively correlated, there will be no diversification benefit. Here, by constructing portfolio, the investors cannot reduce their risk. So here the risk averse investors should invest his money in the security having the lower risk. So we can say that favorable diversification effect will be there when RAB will not equal to 1. That means when security are not perfectly positively correlated, there will be the favorable diversification effect. Now, The second case is that RAB equal to -1. We discussed earlier that two extreme point of the correlation coefficient. Correlation coefficient varies from -1 to +1. So there are two extreme point of correlation coefficient, +1 and -1. So another extreme point of the correlation coefficient between two stock is RAB equal to -1. That means here the security are perfectly negatively correlated. Here perfectly negatively correlated means here if return of stock A increased by 1%, return of stock B will be decreased by 1%. The rate of increase of return for security A will be equal to the rate of decrease of the return of security B. That is why it is called perfectly negatively correlated. Now here maximum diversification benefit can be achieved by an investors, and portfolio risk can be totally eliminated if the proportionate holding in each security determined by setting the first order deviation of the portfolio risk equal to 0 as follows. That means in that case, according to theoretical ground, we can say that whenever RAB equal to -1, that means when securities are perfectly negatively correlated, in that case we can reduce the reduce the portfolio risk to the maximum extent, even it can be equal to 0 also if the diversification is made in a proper way. But now but how the diversification is to be determined, how the diversification is to be made, that is to be discussed now. Here we know that the variance of two asset portfolio, that means sigma p square, is equal to WA into sigma A whole square plus WB into sigma B whole square plus 2 into WA into sigma A to WB into sigma B into RAB. Here in place of RAB we have to take -1 because here RAB equal to -1, securities are negatively correlated. Now the formula takes shape as W into sigma A whole square plus WB into sigma B whole square minus 2 into W into sigma A to WB into sigma B. Now here there are only two securities in the portfolio. Now here WA plus WB will be equal to 1 because total weight is equal to 1. Here WB can be written as 1 minus WA. Now in place of WB, if we write 1 minus WA, then the variance function will take shape as WA square into sigma A square plus sigma B square minus 2 WA into sigma B whole square plus WA square into sigma B square minus 2 WA sigma A sigma B plus minus 2 WA sigma A sigma B plus 2 WA square into sigma A into sigma B. This is the redraft variance equation of the variance function of the portfolio by putting the value of WB, which is equal to 1 minus WA. Now this is the variance function, and for maximum or minimum value of a function, for determining the maximum or minimum value of a function, we have to make the first order differentiation test, and against first order differentiation we have to set the value equal to 0. Now we have to differentiate both sides of this function with respect to WA, because here in this variance function the variable factor is WA, because here sigma A is fixed, sigma B is given, that means fixed. So here only WA is the variable factor. So here with the change in weight of security A, that means WA, how the variance function will change, how the variance will be affected, that is to be determined by differentiating both sides with respect to WA. Now here differentiate variance function in respect to WA, d sigma p square divided by dWA equal to d divided by dWA into the variance function, that is the variance function is to be written here, and that is to be differentiated with respect to WA. Now by differentiating the variance function here, 2WA is equal to WA square will be equal to 2WA, sigma A square is the constant, here it will be attached here. Now changes in sigma B square for changes in WA will be taken as 0 because sigma B is constant. Now here for changes in the WA, 2 WA sigma B square will take shape of 2 into sigma B square, because in respect of WA, here 2 and sigma B square are constant, 2 and sigma B square are constant, and differentiation of WA with respect to WA is 1, so it will take shape as 2 sigma B square. Now here for WA square into sigma B square, that will be changed for changes in the value of WA, and that will be taken as 2 into WA into sigma B square minus 2 WA into sigma B will take shape of 2 into sigma B. Now 2 into WA square into sigma B will be equal to 4 WA into sigma B. So this is the changes this is the change that will be occur in the variance function due to changes in the weight of security A. So this is the first order differentiation of the variance function. Now if we set the for minimizing the value, minimizing the variance function, we have to set 0 against the first order differentiation. Now by setting 0 against the first order differentiation, we have the value of WA is equal to sigma B divided by sigma A plus sigma B. This is the weight of security A. Now we know that WA plus WB is equal to 1. So WB equal to 1 minus WA, and putting the value of WA here, which is detected earlier. Here WA is being detected, sigma B divided by sigma A plus sigma B. Here by putting the value of sigma WA here, we have the value of WB, which is sigma A divided by sigma A plus sigma B. So in respect where securities are perfectly negatively correlated, in that case the investors can derive the optimum diversification benefit if the weight of security A become equal to sigma B divided by sigma A plus sigma B, and weight of security B will be sigma A divided by sigma A plus sigma B. So at the time where RAB equal to -1, for getting the maximum diversification benefit, weight of security A will be taken as sigma B divided by sigma A plus sigma B, and weight of security B will be taken as sigma A divided by sigma A plus sigma B. This is the weight of security A, sigma B divided by sigma A plus sigma B, and this is the weight of security B, that is sigma B divided by sigma A plus sigma B when RAB equal to -1. And if we set weight of security A and security B in that way, then we can get, the investors will get the maximum diversification benefit in this case, and risk of the portfolio will become equal to 0.